The Second World War was a conflict defined by industrial might, where victory belonged to the nation that could produce the most aluminum and steel. In the air, the arms race was on. Bigger guns, thicker armour and heavier bomb loads. But while the world was building metal behemoths, a small design team in England pursued a radical, almost heretical idea. They proposed an aircraft built almost entirely of humble wood, stripped of heavy defences, yet capable of achieving speeds that would leave enemy fighters floundering. This wasn't merely a technological gambit. It was a profound act of strategic rebellion. In a metal-dominated sky, one wooden rebel changed everything, becoming a legend of speed, ingenuity, and psychological warfare. The de Havilland Mosquito was perhaps the single most persistent cause of exasperation for the German High Command and the Luftwaffe. It presented a unique psychological and military dilemma. When British designers first proposed an unarmed plywood and balsa bomber, German intelligence dismissed it as absurd. Why would the British, with their superior access to aluminum, build a plane of wood? It was viewed with contempt, a flimsy toy. The contempt quickly curdled into incandescent rage. On January 30th, 1943, the solemn 10th anniversary of Hitler's rise to power, Reichsmarschall Hermann Göring was set to deliver a major national radio address in Berlin. The moment his speech began, 3 Mosquitoes of the Royal Air Force's 105 Squadron arrived over the capital. Their bombs targeted the central broadcasting station. The roar of the engines and the sound of the blasts were broadcast live across the entire Reich. Göring was cut off, his moment of national glory replaced by a scratchy gramophone recording. For over an hour, the Führer's second-in-command was silenced. He later confessed his humiliation to his staff, with a widely reported statement. "I go mad when I see the Mosquito. I turn green and yellow with envy. The British, who can afford aluminum better than we can, knock together a beautiful wooden aircraft that every piano factory over there is building, and they give it a speed which they have now increased yet again." The frustration was rooted in a critical technical failure. The Germans had simply not anticipated a high-speed, high-altitude wooden aircraft. Their radar systems were optimized to detect large, slow-moving metal structures. The Mosquito's smaller size, streamlined profile and unique wooden construction presented a poor radar cross-section, often allowing it to slip through defenses completely unnoticed. Luftwaffe reports from 1943 showed that the Mosquito's detection rate by early German ground radar was often 20 to 30% lower than that of conventional, all-metal heavy bombers. The Germans attempted numerous countermeasures. They rushed to upgrade their older Freya and Würzburg radar systems, and they diverted increasing numbers of their own night fighters, like the Junkers Ju-88, specifically to counter the Mosquito threat. But the fast, high-flying Mosquitoes were often impossible to engage. Luftwaffe night fighter ace Heinz Wolfgang Schnaufer, the highest-scoring night fighter pilot in history, reportedly found the task exasperating, stating that chasing the elusive wooden aircraft was like trying to catch smoke. This inherent stealth created an impossible operational environment. Every night, German fighter control had to dedicate significant resources to chasing phantom returns, or simply giving up the pursuit of targets that vanished without a trace. Oberstleutnant Hajo Hermann, a high-ranking German bomber pilot, later acknowledged that the Mosquito attacks were a major factor in eroding the morale of the entire German air defense system, forcing them to divert disproportionate resources to counter a seemingly phantom threat. They called the psychological phenomenon it caused Mosquito dread. It was fast, elusive, and versatile. The Mosquito didn't just bomb, it scouted, it fought, it stalked, and it marked targets for the heavy bombers that followed. It was the master of the air, not because of its guns, but because of its velocity and its sheer impossibility. To understand the dread it caused, We must rewind to 1938. The Royal Air Force was preparing for war, but planning for a conventional conflict, when the de Havilland Aircraft Company, led by the visionary Geoffrey de Havilland, proposed a radically different concept. The Air Ministry rejected it, not once, but repeatedly. De Havilland and his chief designer, R.E. Bishop, believed the Air Ministry was fundamentally wrong to prioritize heavy, defensive armament. The new generation of fighters meant heavy bombers, like the short Stirling or Avro Lancaster, would suffer grievous losses. De Havilland proposed a radical alternative: strip away the armour, strip away the guns, and design the plane for maximum speed. The original ministry specification, B-139, was for a 2-engine medium bomber. De Havilland ignored most of it. His proposal designated the DH-98 was to be unarmed, fast, and constructed almost entirely of a material the ministry deemed obsolete. In a famous retort to Air Marshal Wilfred Freeman, de Havilland is reported to have simply stated, "Speed is defence." The use of wood was not a weakness, it was a stroke of genius. Britain had a critical shortage of aluminum, monopolised by fighter and heavy bomber production. Wood, however, was plentiful. Furthermore, the wooden structure, a stressed skin made of a sandwich of plywood, balsa, and more plywood, was lighter and incredibly strong for its weight. This design reduced metal parts to a minimum, freeing up crucial resources. The structure was held together not by nails but by chemical engineering, a synthetic urea formaldehyde adhesive called aerolite. This glue was strong, resistant to moisture, and crucial to the Mosquito's low-drag, perfectly smooth aerodynamic surfaces. This sleekness was key to its velocity. The aircraft had impressive dimensions for a medium bomber, a wingspan of 54 feet and a length of 40 feet. Yet its clean design made it exceptionally fast. The light airframe demanded power, and it received the best available: 2 Rolls-Royce Merlin engines. These V12 powerhouses were upgraded with 2-stage superchargers, allowing them to maintain peak performance at high altitudes, delivering up to 1,680 horsepower each. This combination of lightweight wood and high-performance engines gave the aircraft a maximum speed of up to 415 miles per hour, outpacing contemporary German fighters like the Messerschmitt Bf 109. Crucially, this design was far less labour-intensive in terms of specialist metalwork than a conventional aircraft. A German bomber like the Junkers Ju-88, for instance, required thousands of hours of skilled labour for shaping and riveting its aluminum skin. The Mosquito's wooden shell could be rapidly formed in simple jigs by semi-skilled workers, dramatically cutting production time and cost. The time savings were extraordinary. A Mosquito could be produced in less than half the time of an equivalent metal bomber. Because the Air Ministry had initially refused funding, de Havilland famously self-funded the prototype. When the W4050 first flew in November 1940, it shattered expectations by reaching speeds over 390 miles per hour, leaving the Air Ministry's fastest frontline fighters struggling in its wake. The Mosquito's ingenious wooden shell could be rapidly formed in simple molds, allowing the production to be decentralized and taken up by industries previously outside the main war effort. This meant the DH-98 wasn't built by aircraft engineers. It was largely assembled by craftsmen like Arthur Wren, who owned Temple Pianos in London. Wren's expertise in wood lamination was critical to the process. The Mosquito was constructed using double curvature plywood, a technique involving newly developed phenolic resins to glue thin beech veneers at alternating right angles. These veneers were then shaped in specialized pressurized molds, or autoclaves. The resultant laminates were incredibly strong, light, and perfectly suited to withstand the enormous strains of high-speed flight. This reliance on wood and skilled non-traditional labor was a strategic masterstroke, circumventing the critical shortage of specialist metalworkers and freeing up aluminum for the fighter program. Beyond individual craftsmen like Wren, the Mosquito's production drew on a vast network of woodworking shops, furniture factories, and related trades across Britain, enabling true mass production through collective subcontracting. Under the government's Shadow Factory scheme initiated in 1938, funding was allocated to expand defence manufacturing, integrating small and medium-sized enterprises into the war effort. High Wycombe in Buckinghamshire became a hub for this activity, with local furniture manufacturers such as Ronson, E. Gomer, Parker Knoll, Parslow Furniture, Austin Sweet, and Stiles and Mealing fabricating major airframe components, including fuselages, wings, and tailplanes. Wing spars, crucial for structural integrity, were produced by J.B. Heath and Dancer and Hearn at their Penn Street works, where raw timber was processed into precision-finished elements. Other notable contributors included Waring and Gillow, automotive coach builders like Vanden Plas, Mulliner and Hoopers, all adapting their expertise in curved wood forming and joinery to meet aviation demands. Cabinet makers and carpenters from these firms handled intricate tasks like layering plywood panels and assembling wing ribs, while piano makers applied their knowledge of precise lamination and finishing to components requiring smooth, aerodynamic contours. This collaborative model extended internationally, with production lines in Canada and Australia leveraging local woodworkers, often including significant numbers of women not deployed to the front, to build over 1,200 aircraft, utilizing abundant regional timber supplies like Canadian birch and spruce. However, scaling this decentralized approach presented formidable challenges. Adapting civilian woodworkers to the exacting standards of aircraft engineering required intensive training programs to ensure consistency in tolerances and assembly, as traditional furniture-making techniques had to be refined for high-stress flight conditions. Material sourcing proved problematic. While wood was abundant domestically, the supply of lightweight Ecuadorian balsa for the core sandwich structure faced disruptions due to wartime shipping hazards and global shortages, prompting substitutions with local alternatives that sometimes compromised weight efficiency. Production dispersal in 1942, moving assembly from vulnerable sites like Hatfield in southern England to safer locations such as Leavesden and the Standard Motor Company's Coventry plant, which incorporated automotive assembly line efficiencies, was essential to evade Luftwaffe bombings, but introduced logistical hurdles in coordinating parts transport and quality control across disparate facilities. Environmental factors added complexity. British wooden moulds for fuselage halves expanded and contracted with humidity fluctuations, leading to inconsistencies that Canadian producers mitigated by using stable concrete moulds instead. In tropical theatres like the Far East, early deployments revealed vulnerabilities where high humidity weakened glue bonds and promoted wood rot, necessitating design modifications and reinforced preservatives to maintain operational reliability. Despite these obstacles, the system's flexibility, allowing quick repairs with basic tools in the field, ultimately enabled the output of 7,781 aircraft, transforming a patchwork of woodworking trades into a resilient wartime manufacturing powerhouse. And the production lines provided an enduring legacy, so confident were the piano factory workers in their precision machines that visiting Royal Air Force Mosquito crews would often volunteer to strip off their trousers and have them pressed in the autoclaves, emerging with a knife-edge crease that became a factory custom and a symbol of pride. The men of metal hated the Mosquito, but the men and women of wood turned it into a legend. The skeptics were silenced. They had a bomber faster than a fighter, built from materials they weren't using, and assembled by workers previously outside the war effort. The initial design quickly expanded to an entire family of aircraft. The German High Command's final admission of error was their failed attempt to copy the plane with the Focke-Wulf Tar 154. They simply could not replicate the necessary quality of materials or the specialized synthetic resin glue required. The German project ultimately failed because they lacked reliable bonding agents and the necessary stocks of high-quality plywood, a testament to the sophistication of the Mosquito's seemingly simple construction. The strategic air war was often a blunt instrument: mass formations, area bombing, and indiscriminate destruction. The Mosquito was different. Its speed and surgical precision allowed for a new kind of warfare: the targeted, demoralizing strike. These raids weren't about tonnage. They were about psychological effect. The first major demonstration of this precision came in September 1942, targeting the Gestapo headquarters in Oslo, Norway. 4 Mosquitoes from 105 Squadron, led by Flight Lieutenant P.C. Pickard, flew a round trip of over 1,000 miles at wave-top height across the North Sea, below German radar coverage. They struck in broad daylight, aiming for the building's registry office to destroy dossiers on the Norwegian resistance. The Mosquitoes dropped their payload with surgical accuracy before turning for home, the German defenders paralyzed by the sheer audacity and velocity of the attack. The Oslo raid established the Mosquito's tactical ability. The famous Berlin raids of January 1943, however, established its propaganda power. By disrupting Göring's speech, the British demonstrated that no German city was truly safe, even the capital. This feeling of vulnerability began to erode the German public's faith in the Luftwaffe. The most daring testament to the Mosquito's pinpoint accuracy came on February 18, 1944, Operation Jericho. The target was Amiens prison in France, where 120 members of the French resistance were awaiting trial or possible execution. The mission required breaching the walls to free them while leaving the prison staff quarters untouched. The mission leader was Group Captain Percy Pickard. He told his crews that the margin for error was non-existent. If the bombs hit the wrong spot, they would kill the very prisoners they were sent to save. At treetop height, the Mosquitoes arrived. The first wave attacked the outer walls, breaching them. The second wave blasted the inner walls and guards' mess hall. The attack was executed to the second. Over 250 prisoners escaped, including dozens of key resistance leaders. The success was indisputable, but it came at a high cost. Group Captain Pickard perished on the return. It is important to note the historical debate surrounding the raid. Some historians argue the mission was more symbolic than necessary, as the executions were not immediately scheduled. Regardless, the message sent by Jericho was clear. The Mosquito was an instrument of liberation, capable of achieving surgical results beyond the scope of any other aircraft. A less known, but equally important raid demonstrating Mosquito precision was the attack on the Philips radio valve and component factory in Eindhoven, Netherlands, in December 1942. This was a critical facility for German military radio production, and the intelligence indicated that a precision daylight raid was the only option to shut it down quickly. The Mosquitoes flew over 250 miles at masthead height, enduring constant flak from anti-aircraft guns. The objective was the power station and key machinery buildings within the complex. The attack was executed by a wave of Mosquitoes, each dropping its payload with extraordinary accuracy, crippling the factory's production capabilities for weeks. The combination of high speed and low altitude was the only way to penetrate the dense daylight defenses and deliver such accurate strikes, affirming the Mosquito's unique ability to execute missions deemed impossible for conventional bombers. The Mosquito's speed and navigation skills also made it invaluable to Bomber Command. Equipped with advanced navigation radar, Mosquitoes became the pathfinders, flying ahead of the heavy bomber stream to accurately mark targets with flares. Crucially, the Mosquito's low-drag, high-speed design gave it a loss rate of only 0.7% per sortie, far lower than the 2.2% loss rate of the heavy bombers. It was delivering an equal amount of explosives per aircraft lost, but with a fraction of the crew casualties. The role that truly embodied the Mosquito's psychological impact was its shift to being a night fighter, turning the hunted into the hunter. German night fighter pilots were already facing the heavy strain of hunting hundreds of bombers, but the introduction of the Mosquito as an opponent broke their morale. The Mosquito night fighter was equipped with the latest airborne radar. Initially using older sets, it quickly transitioned to the highly effective centimetric radar. This small, powerful radar was almost impossible for the Germans to detect or jam early in the war. The Mosquito's ability to sneak up on German night fighters was critical. By using specialized detection equipment like Surratt to home in on the emissions from German radar sets, the Mosquito crews could track the hunters, turning their own technology against them. The dread became so intense that one German pilot confessed, "We knew they were there, but we couldn't see them. We'd be focusing on the Lancasters, and suddenly the Mosquito would come out of the darkness and tear into us. It was a terror without substance. You were never safe." The Mosquito also served as an intruder. Flying low, often alone, it haunted German airfields, attacking Luftwaffe fighters during takeoff and landing, disrupting their cycles and denying them rest. This added relentless pressure to an already exhausted force. In 1944, the Mosquito found a new vital role defending Britain. When Hitler launched the V-1 flying bombs, or doodlebugs, against London, only a few Allied fighters could catch them. The Mosquito was one of them. The aircraft's high-speed performance at medium altitudes made it the ideal interceptor for the V-1s. Mosquito pilots were credited with downing approximately 600 V-1 flying bombs, a massive contribution that represented nearly 25% of all V-1 intercepts achieved by Allied aircraft during the campaign. If they ran out of ammunition, Mosquito pilots would fly wingtip to wingtip with the V-1, carefully slip their wing beneath the stubby wing of the missile, and gently tip it. This maneuver would upset the V-1's simple gyroscope, sending it harmlessly plummeting to the ground. It was an act of incredible nerve, performed at nearly 400 miles per hour. Beyond the air war, the Mosquito also devastated Germany's maritime supply lines. Specialized versions were armed with rockets and even a massive 57mm cannon, a modified anti-tank gun, earning them the nickname the Tetsi Mosquito. The Tetsi version was a terrifying sight for German U-boat crews and merchant mariners. Its primary weapon was the enormous Ordnance QF 6-pounder anti-tank gun, automatically loaded, firing high-explosive shells. The gun was mounted in the nose, replacing the original 420mm cannons. The Mosquito was the smallest, fastest aircraft ever to carry such a heavy-caliber weapon. The recoil from the 57mm cannon was immense, requiring structural reinforcement and specific crew adaptations to manage the sudden lurch. The tactics were ruthless. In the Baltic Sea operations of 1944-45, the Mosquitoes would attack at wave-top height, aiming the 57mm shells directly at the U-boat's conning tower or the merchant ship's waterline. This single-shot destructive power allowed them to punch holes through reinforced steel plating, effectively sinking or crippling German coastal shipping with unprecedented speed and efficiency. By the end of the war, Mosquito strikes had accounted for the sinking of dozens of vessels and several operational U-boats, contributing significantly to the blockade of German supply routes. The devastation was comparable to, or even exceeded, that achieved by heavier anti-shipping aircraft like the Bristol Beaufighter, due to the Mosquito's superior speed and low loss rate. All of these roles, from high-altitude reconnaissance to low-level anti-shipping strikes, were performed by just a two-man crew, the pilot and the navigator. This dynamic demanded an exceptional bond and mutual reliance, especially under the constant threat of enemy action and crippling crew fatigue from sustained high-speed, high-G maneuvers. Pilot Albert Smith, a Mosquito Pathfinder, recalled the unique thrill and risk of operating the aircraft. The Merlin engines were like a symphony, a constant, powerful roar. You felt like you were wearing the airplane. When you pushed the throttles forward, nothing, absolutely nothing, could touch you. You were a wooden god, and the world was moving in slow motion beneath you. The navigator, seated beside the pilot, faced unique demands. On a typical low-level raid into occupied Europe, the navigator had to execute complex dead reckoning navigation at speeds often exceeding 350 miles per hour, without the luxury of radar assistance until the last moment. They had mere seconds to identify the target, confirm the altitude, and give the final bombing instructions. The navigator's job was described by some as flying a typewriter at 300 knots, highlighting the mental strain and the need for absolute synchronization with the pilot. Yet, even the Mosquito paid a price. The low-level precision attacks, while effective, meant exposure to intense ground fire. Over the course of the war, more than 400 Mosquitoes were lost in bomber command operations. Allied challenges, such as early structural issues stemming from glue failures in humid climates, often led to tragic mid-air disintegration. The speed was their defense, but when speed failed, the aircraft's lack of armor meant the crew had virtually no chance. The physical demands of low-level flying were intense. The aircraft's light wooden structure transmitted every vibration and air disturbance directly to the crew. Pilots often reported extreme physical exhaustion after just a few hours of flying at near treetop height, dodging obstacles, and enduring violent evasive maneuvers. One pilot summarized the sensation. It wasn't flying. It was like driving a racing car down a cobblestone alley at maximum speed, in a hurricane. The crews themselves represented the full scope of the British Commonwealth war effort, with significant contributions from pilots and navigators from Canada, Australia, and New Zealand. These two-man teams, often trained rapidly, took on responsibilities previously assigned to crews of 5 or 7. Their sustained effort and specialized low-level training became the silent core of the Mosquito's success, forging lifelong bonds and, sometimes, enduring the loneliness of returning without their comrades. The true measure of the Mosquito's genius lay in its adaptability. The clean, lightweight airframe allowed de Havilland to quickly spin off variants for almost every conceivable mission, fulfilling the role of an entire small air force. The most numerous was the FB Mark VI fighter bomber, a heavily armed workhorse that combined 4 20mm cannons with a bomb bay and the capability to carry 8 high-explosive rockets under its wings. These were the planes that would sweep across occupied Europe, mercilessly targeting railway lines and German supply convoys. For pure intelligence, the PR Mark 16 photo reconnaissance models were stripped of all weapons and loaded with specialized fuel tanks, allowing them to fly above 35,000 feet to capture critical images for operations like D-Day, missions they accomplished with relative impunity. Finally, showcasing the extreme limits of the design, the specialized Tetsi Mosquito was created, mounting a massive 57mm anti-tank cannon in its nose to punch through the hulls of U-boats and coastal shipping. This family of aircraft was rapidly iterated, ensuring that even as the nature of the air war changed, the Mosquito was never obsolete, remaining a cutting-edge weapon right up to the final days of the conflict. When the war in Europe ended in May 1945, the Mosquito had flown an estimated 39,000 operational sorties. It had conducted vital reconnaissance, guided the main bomber force, and executed strikes that were as effective for their morale-shattering effect as they were for their physical destruction. They dropped the equivalent of over 25,000 tons of bombs. They were responsible for the destruction of hundreds of German aircraft and neutralized countless ships and critical infrastructure targets. Furthermore, the use of wood for the fuselage saved the British government thousands of tons of aluminum, a resource critical to fighter and heavy bomber production. Estimates suggest that the Mosquito program conserved approximately 5,000 tons of aluminum, freeing up that metal for the production of over 1,500 Spitfire fighters. The constant irritating presence of the light-night striking force forced the Germans to divert vital resources, fuel, crews, and fighter production, away from the Eastern Front and defense of the Reich, straining an already overstretched military. German estimates indicate that the constant deployment of night fighters against the LNSF resulted in the consumption of an estimated 30,000 tons of aviation fuel, a critical resource diversion in the last years of the war. An aviation historian summarizing its significance noted, "The Mosquito fundamentally changed the nature of air power. It proved that light-fast two-man teams could achieve what entire heavy bomber groups were struggling to do. It was the ultimate expression of the fighter-bomber concept, speed over guns. It was an evolution years ahead of its time." The Mosquito service did not end with the war. Its reliability, speed, and versatility ensured its use continued in the post-war Royal Air Force for over a decade. It saw significant action in the Malayan emergency as a ground attack and reconnaissance platform, finally being retired from service as late as 1956, often in the role of a high-speed target tug. Its global service continued, notably with the Israeli Air Force, which flew the Mosquito during the 1948 Arab-Israeli War for reconnaissance and light strike duties, demonstrating the aircraft's enduring value in complex conflicts. The design philosophy, centered on speed, low visual observability, and mission specialization, became a blueprint for post-war military aviation. Its influence can be seen in the design of high-speed jets like the English Electric Canberra, which also relied on speed and altitude for defense. The multi-role concept, a single airframe adapted for numerous specialized tasks, was perfectly realized by the Mosquito and is the foundation for modern platforms like the FA-18 Super Hornet and the F-35 Lightning II. Even the use of non-human specialized components where the crew is the highly trained sensor and weapon system foreshadows unmanned platforms like the MQ-9 Reaper drone. Fundamentally, the Mosquito's inherent radar evasion, a consequence of its non-metallic structure and composite materials, makes it the spiritual ancestor of modern stealth principles embodied by the B-2 Spirit and the F-117 Nighthawk. The Mosquito, the wooden wonder built by piano makers, was not just an airframe. It was a bold idea, a fast, elegant, and uncompromising machine that exposed the rigidity of German command, brought dread to the hearts of their pilots, and delivered victory through sheer untouchable speed. The Mosquito's story transcends military history. It has embedded itself deeply into popular culture as the quintessential wooden wonder. Its sleek, purposeful lines and improbable construction made it a favorite subject for model makers and aviation artists long after its retirement. The film 633 Squadron cemented the Mosquito mythos, capturing the dramatic, low-level flying and heroic sacrifice associated with its missions. Veteran memoirs, such as those by the Pathfinders, continue to be read, keeping the human stories of the two-man crews alive. Today, the Mosquito remains an object of intense reverence and costly restoration. Examples are preserved at major institutions like the Royal Air Force Museum and the de Havilland Aircraft Museum. But the most spectacular tribute comes from those who restore them to flying condition. To hear the powerful, rhythmic roar of the two Merlin engines overhead is to experience a direct link to the defiance and ingenuity of the Second World War. The Mosquito taught the world that you don't win the air war by being the biggest or the most heavily armoured, but by being the one they simply cannot catch. And for this ultimate expression of speed and audacity, it remains, until the very end, perhaps the only Allied aircraft the German High Command truly, completely despised.